Hello everyone, thank you very much for watching my video today. And in this video we're going to continue our journey of solving systems using Gaussian elimination. But we're going to take a look at a couple of very special cases. So here we have our three variable system here that we're going to try to solve. So let's set up our Gaussian elimination. Let's set up our matrix of numbers, of coefficients. All right, now if I want to start eliminating that, let's start by eliminating the x's, right? So copy down my first row here. All right, now for the second row, I'm going to do -2 row 1 plus row 2. -2 plus 2, 6 minus 1, and then -2 minus 2, and then -2 plus 2. Okay. And then for the third row, I'm just going to do row 1 minus row 3. So 1 minus 1, -3 minus 2, 1 plus 3, and then 1 plus 1. All right, now let's eliminate the y's for the third row. All right, to eliminate the y's for the third row here, we're going to do row 2 plus row 3, and I get 0. 5 minus 5 is 0. -4 plus 4 is 0, and 0 plus 2 is 2. So we got 0x plus 0y plus 0z equals 2. That's probably not possible. What does that mean? Well, we should end up with something like this. Now, we didn't get exactly what I have here, but it's the same gist here. You got all zeros for the variables and then a constant on the other side. That's not good. That means it's actually impossible. And for this system, we actually call this something called inconsistent. So we call this an inconsistent system. Okay, let's take a look at the second one here. Again, let's start by setting up my matrix of constants. 1, 1, -3, -1, 0, 1, -1, 0, -1, 2, 0, 1. All right, if I want to start by eliminating the x's here, well, the second row already has those x's eliminated, so that's great. And for the third row, I'm just going to do row 1 minus row 3. Sorry, plus row 3. So 1 plus -1 is 0. 1 plus 2. -3 plus 0. -1 plus 1. Okay, so good news. The x's are eliminated. All right, now let's take our last two rows and try to eliminate the y's. So I'm going to do -3 row 2 plus row 3. All right, so that'd be 0. -3 plus 3 is 0. 3 minus 3 is 0, and then 0 plus 0 is 0. So that gives us 0x plus 0y plus 0z equals 0. Is there anything that we can't put in there for x, y, or z to make that true? The answer is no. We can put anything for x, y, or z in there, and it's always going to be true. So we should get something like this, which we did. Okay, it's not exactly the same, but it's similar because we get this bottom row here, which is true for all x, y, and z. Okay? For this system, there are infinitely many solutions. We call this dependent. Okay? So inconsistent means no solutions. Dependent means infinite. Okay? And then there is one more kind, the one we've been doing for the last day here. If you have one solution, we just call that an independent system. So at this point, you should pause this video. There are 3 for you to try. Go ahead and try those 3, and then when you're done, you can come back and check your answers. Number 3 should be inconsistent. Pause here if you want to keep looking. Number 4 should be dependent. And number 5 should also be dependent. All right, and that's it. That's going to do it for our video today on special cases using Gaussian elimination. Thanks as always for watching, and we'll see you again next time.